Assalamu alaikum warahmatullahi wabarakatuh, my dear students. You are welcome to our class for today. In the previous class, we did application of differential calculus, where I made mention about the two different applications. One is the use of differential calculus to obtain the gradients of a given curve. And the second was the use of application of differential calculus to obtain the equation of the tangent and normal to the curve. But because of the number of turn of the assignments, all of you are here to submit your assignment. Only few of you have submitted the assignment so far. So for that reason, we will not be able to do the correction of those assignments. Now, inshallah, in our subsequent class, we are going to do the correction of those assignments together with the correction of the assignment that I'm going to give you today. Now, the third application of differential calculus I want to look at is the velocity and acceleration. The use of differential calculus to obtain the velocity and acceleration of a body. And we all know from I know more than 50% of you are science students, so you know what I mean by velocity and what I mean by acceleration. You have earlier defined velocity in your physics as the rate of changing of body displacement with time. The rate of changing of body displacement with time. Or in some textbooks, they say the rate of changing of the body speed with time. And acceleration is the rate of changing of velocity with time. That means from the statement, we can get velocity by differentiating our displacement. That means our velocity. I said here that if s is the distance or displacement at time t seconds, then velocity v is what? ds over dt. That means the derivative of x with respect to t will give you your velocity. And similarly, your acceleration will now be dv all over dt. That means acceleration is equal to the rate of changing of velocity with respect to time. So example is given here. Don't forget, what we are doing for the SS3 class is to pick some topics we have done, because virtually we are through with all our syllabus. So we only be picking some topics that I know you are having some difficulties, and we'll be doing 2 or 3 examples before we now move on with the solution of series as we normally do. So the example one I have here is that we are given the distance s in meters. Distance s meter traveled by a body in time t seconds is given by the equation. It's given by this: s is equal to t cubed minus 2t, minus t squared minus 3 plus 4. So it's given that s is equal to t cubed minus t squared minus t plus 4. We have to determine the velocity and acceleration after 5 seconds. And the second thing is that we should find when its velocity is 0. When its velocity, the statement means that we will find the time. It is not in all cases that we will be told to find the time. It has to, when its velocity is 0. That is, you should find the time at which the velocity is 0. Then the second one says when its acceleration is 0. So we want to solve the first one. We are given that s is equal to t raised to power 3 minus t squared minus t plus 4. So we know that our velocity is equal to the s all over dt, that is the rate of change of body displacement or distance with respect to time. So that if you differentiate this, you have 3 times t raised to power 3 minus 1, and that is what? 3t squared minus 2 times t raised to power what? 2 minus 1. That is 2t raised to power 1, which we don't need to write 1. And the derivative of this, of course, it is minus 1. The derivative of the constant, you know that one is 0. So if you differentiate 4, you have 0. And that's our velocity. So at time is equal to 5 seconds. At time is equal to 5 seconds. Then at time t is equal to 5 seconds, then our velocity is equal to 3 open the bracket 5 all square minus 2 open the bracket. Our t is what? Our t is 5 as usual, then minus 1. So this is equal to, if you square this, you have what? You are going to have 25. 25 times 3, that is 75. Minus this and this will be what? 10. Then minus 1. You subtract this, you have, this is 65, then minus 1, that's 64. You now have 64 meter per second. Don't forget that this displacement or distance is in meter, while the time is in seconds. So distance divided, meter divided by seconds will give you meter per second. So that is our velocity at which the time is equal to 5 seconds. Then our acceleration, we know that acceleration is equal to dv all over dt. That is the rate of change of body velocity with time. So this is equal to, if you divide, don't forget that but our velocity has been earlier got to be what? 3t squared minus 2t minus 1. That means a, which is equal to dv all over dt, will now be equal to what? 6t minus 2. That is 2 times 3, that is 6, raised to the power 2 minus 1, that is 1. And we don't need to write 1. Of course, we are not the beginner, or we are not beginner in mathematics, so we don't need to write that. So if you differentiate this, of course, you have this. And you differentiate minus 1, you have 0. So at t equal to 5 seconds, then our acceleration is equal to, so acceleration is equal to what? 6, open the bracket, 5 minus 2. And a is equal to 6 times 5 is 30, minus 2, that is 28 what? Meter per second square. Meter per second square. So that is that. Then the second one, B, we are asked to find when the velocity is 0. We recall from our previous solution, recall that our velocity, which is equal to the s all over dt, we got what? 3t all squared minus 2t minus 1. So v equal to 0 implies that 3t all squared minus 2t minus 1 is equal to 0. So this is quadratic equation. So we need to solve this quadratic equation. Using any of the suitable method, but I prefer that we should use what? Factorization method. So we have 3t squared minus 2t minus 1 is equal to 0. Take of number, which one you have together, you have minus 2, and when you multiply, you have what? Minus 3. And the number, of course, it will be what? Minus 3 plus 1. So the factors are minus 3 plus 1. So you have 3t squared minus 3t plus what? 1t minus 1 is equal to 0. So 3t is common to both sides. I can bring 3t out. Here I'm left with what? T minus 1. Here also 1 is common. So I can bring 1 out. I'm left with what? T minus 1 is equal to 0. So that means that 3t what? Plus 1. Close the bracket. Then t minus 1 is equal to 0. So that means 3t plus 1 is equal to 0, or t minus 1 is equal to 0. So from this, of course, t, if you transfer this to the other side, you have minus 1. And you divide that by 3, you have t to be equal to minus 1 all over what? 3 seconds. Or t is equal to 1 second. So these are the time that the velocity will be 0. These are the times that the velocity will be 0. Then the last one asks us to find what? It asks us to find the time when the acceleration will be 0. Don't forget that our acceleration, that is c, our acceleration is equal to what? dv all over dt. Is equal to dv all over dt. So acceleration, which is dv all over dt, we have earlier established that to be what? To be what? 6t minus 2. So if this is 0, if a is equal to 0, what it implies is that 60 minus 2 is equal to 0. That's what is implied. This implies, or if that is that, then our 60 minus 2 is equal to 0. That means 60 is equal to 2. And that means t is equal to, we divide both sides by 6. Of course, we have 2 all over 6. So t is equal to 1 all over 3 seconds. So this is the time at which the acceleration will also be what? Zero. So that is that for the example 1. Then the second example, we are told that example 2. Example 2. We are told that the speed s of a particle after time t seconds is given by v is equal to 7 plus 25t minus 4t squared. That is the speed that we are given. Then we are asked to find the what? We have to find the acceleration of the particle after 2 seconds. Solution. In this occasion, we are told that the speed s of a particle after time t seconds is given by v is equal to 7 plus 25t minus 4t squared. Then we have to find the acceleration. It means that we have already been given the velocity. That's just the meaning. Because we know earlier that our speed is this over time. That means the rate of change of the body distance with time, with travel to time, which is the same thing as when you are dividing velocity as the rate of change of body displacement with time. So definitely we have been given velocity, even though from the question here we are given v, which is the velocity. Definitely to get our acceleration, we are going to differentiate once to get the acceleration. So our velocity has been given to be 7 plus 25t minus what? 4t squared. So acceleration, which is equal to v all over the t, is now equal to, if you differentiate the constant, you have 0. So the derivative of 7 will be 0. If you differentiate 25t, you have 25. Then if you differentiate this, you have what? This and this, that is 8t. So that means that our acceleration is equal to 25 minus 8. Then at t equal to what? 2 seconds. At time is equal to 2 seconds, our acceleration is equal to 25 minus 8, open the bracket, into 2. And that is what? 25 minus 16. And that is what? If you subtract that, you have what? Subtract that, you have 9 meter per second square. Don't forget the unit. It's very essential. It's very important to put unit. If you have done this in a whiteboard never without putting the unit, or you have put wrong unit, it is minus 1. So take note. So that is that for application of differential calculus. Inshallah, in the subsequent class, we are going to solve the correction of the assignment I'm going to write now and the other assignment that you have been given earlier. So you solve this as an example. It's just a question you have with the assignment I've given you so far. Then inshallah we'll meet on Wednesday. We are going to solve the correction before we now move to integration. So assignment. The velocity v in meter of a car traveling is given by V is equal to 5 plus 3t minus 1 all over 2t squared. A, calculate the acceleration when omega 1 t is equal to 3 seconds. Let me write the seconds in word so that I do not take it as 35. 3 seconds. Omega 2 t is equal to what? 5 seconds. Then question B said, at what time? At what time is the acceleration 0? At what time? I'm not write it yet. Maybe you did not see that one. That is B said, at what time is the acceleration 0? So that is the example. That is the assignment that you are going to solve. Inshallah, we are going to meet on Wednesday to solve the correction of all the assignments. The first assignment I gave you and the second one. Inshallah. Subhanahu wa ta'ala. Wa billahi sa'ata ma yadku. Wassalamu ala al-mursalin walhamdulillahi rabbil alamin.